Bienvenidos a todos. Muchas gracias por estar aquí. Soy Andrea Guidi de Software Products. El tema de la presentación es detallado y aborda un aspecto crucial, las aplicaciones en, en línea, aplicaciones online, tiempo real. La razón de la latencia de la respuesta y una forma de solucionarla. Detrás de una iteración del usuario, si tienes una ventana online, ejemplo, para hacer un ejemplo, un sistema, aplicaciones bancarias o financieros, atrás de esta ventana, atrás de una interacción con el usuario, pueden haber decenas o incluso centenares de transacciones. Antes de empezar, me gustaría agradecer a Sebastian Emmerling de Aerospike, del marketing, por todo el soporte dato que ha dado este evento, a Pierre Berard, director europeo de Aerospike, y a la colega Ana Marotto de Software Products del marketing. Así, la velocidad de las aplicaciones se centra en las transacciones en tiempo real, en un contexto en línea, con grandes cantidades de datos y a menudo múltiples fuentes de datos, como así son muchos sistemas actuales. Veremos por qué, lamentablemente, la velocidad de la aplicación es igual a la velocidad de la transacción más lenta. Lo veremos en términos específicos. Lo veremos con Nicolás, ingeniero de soluciones de Aerospike. Dos palabras sobre Aerospike, que es una empresa, es una solución. Es una base de datos NoSQL distribuida, con lectura y escritura increíblemente rápidas. Es una base de datos a altísima disponibilidad. Sus características, estas características de altísima velocidad de disponibilidad, le permiten utilizar, que sean utilizados durante su ejecución con ellas, los modelos de inteligencia artificial más precisos que existen ahora. El objetivo es de escalar y al mismo tiempo reducir los costos operativos. Software Products, mi empresa, es un distribuidor a valor. Como dice nuestro payoff, este redondito a la derecha en alto, este eslogan, Let's Innovate Together. O como queremos, lo que queremos que diga es refleje tres valores importantes que son la innovación, lo team y la partnership. Partnership no solo con el cliente, desde luego, pero también con el vendor. Partnership, one team y innovación son lo que nos han llevado a Aerospike. Ok, después de esta pequeña introducción en la cual voy forma corta, voy a introducir unos dos aspectos que Nicolás va a desarrollar en su presentación. Hay la presentación de Nicolás, que es el centro, el corazón de esta presentación. El por qué una aplicación es tan rápida cuanto su transacción más lenta y una posible solución. Luego vamos a presentar un caso de éxito, que es el caso PayPal, que explica bien todo lo que, o aplica bien todo lo que Nicolás nos va a decir. Quiero introducir sustancialmente dos términos. Me disculpo con todos todas las personas que ya conocen muy bien estos términos, pero puede ser que faciliten la comprensión de la presentación de Nicolás. El primero es de P99. P en este caso se entiende percentil en el específico. Si miramos los tiempos de respuesta de un sistema durante un periodo suficientemente largo, tomamos todos los tiempos de respuesta en este periodo y luego ponemos esos tiempos del más lento al más rápido en orden y tomamos el tiempo del punto intermedio de esta secuencia. Esto se llama P50, el percentil 50. Si P50 será un tiempo T, entonces podremos decir que todo el 50% de las transacciones se actúa en un tiempo menor de T. Si en cambio vamos a tomar los 9 décimos de esta secuencia, entonces tendremos el P90 y este T, el T del P90, el tiempo de espera del T90 será, podremos decir que, que el 90% de las transacciones de las iteraciones, por ejemplo, en el caso específico, son más rápidas de T, etcétera, etcétera, P99, P99.9. Es evidente que la introducción de una cache, una memoria intermedia, en cualquier forma, ¿no? de las mil formas que se puede introducir una memoria intermedia, más rápida de la memoria masa, la memoria masiva, y menos rápida de la RAM, de la memoria central, pero más cara de la RAM y menos... la voy a repetir. Es evidente que la introducción de una cache, una memoria intermedia entre la memoria principal y la memoria masiva, en un sistema de almacenamiento, modifica el perfil de la latencia global. Pero hay que considerarse que independientemente del tipo de cache o de algoritmo que se utiliza, hay la posibilidad que el dato que necesitamos no esté en la cache, que se deba ir a buscar en otro lugar. Entonces, con rate de la hit, con hit rate, tasa de acierto de la cache, o sea, como decir en palabras no ingleses, l'hit de la cache es la probabilidad que el dato que necesitamos esté en la cache. Estos dos aspectos son aspectos que hay que considerar en la presentación de Nicolás. Percentil y hit de la cache. Doy, Nicolás, la palabra a Nicolás. Gracias.
Hello everyone, I'm Nicolas, I'm based in France, and the topic today is really to help you understand why leveraging real-time transaction can be really important in your applications, and understand also what it means to have real-time transactions. So the two presenters for today are my colleague Andrea, who will be joining soon, and myself from Aerospike. So we will discuss these technologies. So basically the content, you will have an introduction about the topic, what you can expect, what are real-time transactions, why are they important. Then I will have a presentation of what we say, why is your application as fast as your slowest transaction? So what it means exactly to say that your application can't be faster than the longest response time you can have on the back end of the application. We will show you some example around fraud prevention and detection, especially the PayPal use case, which is leveraging Aerospike for fraud detection and prevention. And you will have time to ask your question, and we will try to answer it the best we can. So it was supposed to be in Italian, so sorry, you have a few words in English, but the idea is really to get you the understanding. So I will skip this slide and get started with the proper presentation. As soon as Andrea will join, he will be able to talk about it in Italian. So the technical presentation is really about common application design and what you are doing right now. So in the current world, when you develop an application, it's really common to try to serve thousands of users, millions of users, perhaps billions of users. And in the application, in that case, you will have multiple app servers serving different purposes. So the application by itself is not a single binary. It could be multiple microservices, and all of them will run in their own servers or containers. But at the end of the day, they are sharing the same kind of data. So they will rely on a database. And the more you scale, the more it's complicated to serve data directly from the database, especially if you are using some SQL database, just like MySQL, Postgres. It can be really slow to access the database. So a standard is just add a distributed cache. So you add something like Redis or whatever it is, but you start storing the data outside of the database just to ensure that you will have a faster response time. So it will also prevent some pressure on the database, because the database can be slow, not necessarily because you have too much data, but because you have too much pressure.
Ora lì mi sembra abbia ripreso, però non so se lo senti. Ora chiaramente hanno fatto tutto in inglese. Senti se senti diretto o no.
I'm hearing someone.
Yeah, done.
So I will just continue. So basically the idea is the cache is not designed for storing long-term data. So it's really a thing that in your application, you have to, as soon as you leverage the cache, you need to keep in mind that some of the data will be stored in the cache, but every time you update data or you create new data, you will store that to the database, and you will need to go back to the cache and move the data around. So the usual flow you have in an application, in that case, is a user is sending a request to your application. One of the instance, a load balancer, will receive that and send the request to the proper component of that. So it could be one single binary, it could be multiple microservices. We don't know, but you will send all the elements. The services will receive the request, or part of the request will check the data in the cache. If they can find the data in the cache, it will retrieve that and send that back to the global service. If it's not in the cache, basically we'll go to the long-term storage, so the RDBMS application, and it will grab all the data needed, write the receive result to the cache, so the next time you won't need to go back to the database and go directly from the cache and continue. And you repeat the action in tree for all the services you have, or all the components of your application you have. And once you have all the different parts of the answer for this specific user request, you can aggregate everything and send the result back to the user. This is really a common pattern in application. It's not, I'm not trying to create something new by saying that. It's really what we can expect from an application today. Just to show you an example of that, this is the French website Leclerc. So it's an e-commerce platform from a really well-known retailer. And I have no account on this for this retailer. I'm not using it. It's not just connected to the landing page. And if you look at the details on the right of the screen, you can see that just accessing the landing page, you have 20 web service requests. So I'm not talking about getting the images or getting the style sheet or whatever. It's just getting to web services. So it means that just landing page of a standard retailer today is at least asking 20 backend services. What do I need to serve to this user? And I don't know this user at this moment. I have no authentication, nothing like that. I'm just, what do I need to show and how does it work? Excuse me. So if you think about this, the usual issue is if you check the data, if they are in the cache, if yes, you can continue, that's fine. But if no, what's going on? What it means for your response time? Because as you have seen in 20 web requests, it means that perhaps you have more than that on database access. It's just 20 components, 20 different components that are serving one page. So if one of them is just slow for 1 second, 2 seconds, a minute, I don't know, what it means for the global response time for the landing page. The other part is if the data are not in the cache, or you are serving data that are in the cache but that are perhaps really old, what it means to what you're showing to the users. Because perhaps you are showing promotion on the website or the landing page that are no more relevant or no more accessible because they are already sold out. So what it means in that case for your brand reputation, because if you are showing promotion that the people can't use, they would say, okay, this is just a trap. I don't want to go back to this website. And the question for specific to this topic is, how many databases and cache requests you have really done? Because I have seen 20 services access, 20 components to serve the website, the landing page, but how many of them have done a request to a database or request to a cache? The problem with that is usually the slowest transaction or the slowest request you will have on a website or on an application is always when you're reaching the database. It's really common that the database is taking 2, 5, 10 milliseconds to give you an answer. So it's really common. And on this new services, new way of designing an application, it's not uncommon to have one component reaching 5 to 10 times to the database. So for every HTTP request you have on the landing page, you have 5 to 10 database access. So if we consider that you have 10 database access for the cache, for the RDBMS, for whatever it is, per HTTP request, so we consider that only a half of the web service of the web component you have reached for the landing page are asking data in the database, only a half of them. So every time you have 10 times access to the landing page, you have 100 HTTP requests to the databases or to the cache. So it means that when we think about the problem of P99, every 10 times you are showing the landing page, statistically speaking, you hit the tail latency once, every 10 landing page show. So it's a really important problem to understand the tail latency and what it means on the database. And it's really an easy case and easy numbers. I'm pretty sure that the 20 components we have seen are accessing the database, all of them, and perhaps accessing 2 times the database. So it's really frequent that you are hitting the tail latency. So the solutions that we have seen, and I have explained at the really beginning, you can cache hot data. So basically it means that every time you are accessing some part of the data, you put that data into the cache. It's really easy to do because, let's say, the landing page is the web page everybody is going to at first. So you will store all of the component of the landing page into the cache, so it's fast and etc. And then you will have to implement some LRU algorithm or TTL to manage the cache and ensure that what you are showing on the landing page or the web page is something interesting and relevant at the moment and consistent with the state of the data. This solution, this is really the most common solution we have seen in years, and this is still the one that many people are using because this is really easy to leverage. Create a cache, access the cache, and you're good. The problem is you still have no clue of what is the tail latency you will experience and what is the global latency of your website user will experience. Just because the way the cache is managed, perhaps you are not showing the right data, or perhaps you can't find the data into the cache. And it's nearly impossible to ensure that all the data that are relevant for your website will be in the cache every time. So really often you will hit the SLA, and you can't say, even if the cache is 1 millisecond response time, and so basically your web page is 20 millisecond or 100 millisecond response time. But at some point in time, you are sure that the tail latency, that when one of the requests sent by a user or a few of them will hit the database, and all of a sudden it's not 100 millisecond response time, it's 150 milliseconds, the time to access the data, move that data back to the cache, and etc. So your SLA can't be better than the tail latency that you will have, because people, if you are saying, hey, my website is 100 millisecond response time, but 10% of the requests are hitting in 150 milliseconds, it means that 10% of the time you are not aligned with the SLA. The other solution that you can leverage is to use an in-memory database. So basically you say, okay, the cache is fast because it's storing the data in memory, but I'm not sure that, do I have all the data I need? So I will move my database to the memory space. So it will be easier. Everything will be accessed directly from memory. The disk is more or less used only for backup storage or cold start of a node, or etc. But everything will be managed directly by the in-memory database. And in that case, as memory is more volatile than disk, usually you will start creating a distributed system with a replication factor of 3. This is really the common usage. So you will copy the data 3 times across different nodes. So in case of a node's failure, you have not lost all the data that you are storing in memory. The problem with that is, in fact, the response time is only guaranteed until you can store all the data in memory. And by that, I really mean all the stuff you want to store. So if you want to store 1 terabyte of data, you need to store 1 terabyte of data in memory and replicate that 2 times, 3 times. Because as soon as you leverage the disk access of an in-memory database, because not everything is in memory by design, then in that case, the disk access will be really slow, and you go back to the previous problem of not being able to access all the data as fast as possible. The other problem with that is usually the memory is not directly managed by the system at the query time. So when you create something, it will insert the data into the memory immediately. But when you delete something, it's usually marked for deletion, and you have another process that will go through all the data marked for deletion to reclaim the space available in memory. And then you will have also to manage the replication of that. So the garbage collection that will reclaim the space can take a long time, and you don't know what's the impact, and you can't really prevent the impact of this specific process on reading the other data. You are not sure that this process is not holding back your response time because it needs to travel some memory space where your data is residing at some point in time. And once again, when you are storing the data, you need to replicate them. So if I'm still at 1 terabyte of data, my example, it means that you will need to have 3 terabytes of memory globally to store everything and replicate everything. So the idea is to explain how Aerospike is working in a different way and how it will help you leverage the response time of the cache without the worries of the cache. So basically, Aerospike is just a NoSQL database that is storing data on disk, or this is a patented approach. But the way we are storing data on disk is really different than the way other databases are using the disk. And put it in simple words, it means that if you want to store 2 terabytes of data, it's always cheaper to have 2 terabytes of SSD disk on the server than having 2 terabytes of RAM. But Aerospike will show you that you can have the same response time. The way this is done is by an approach that we call hybrid memory architecture. And basically, Aerospike is directly accessing the block interface. So we are not asking the operating system, hey, I want to read data on that specific file. So the operating system in that case will ask to create page cache and grab some data from the block interface to the SSD, send them back to the page cache, look at all the data that we were requesting, put that in a handler and answer to the process. Aerospike is basically avoiding all of that. And as soon as you're requesting for some data, Aerospike will directly go to the block that is storing this specific data. It will prevent a lot of override time directly on the system and ensure that you will have the correct data as fast as possible, but still keeping everything on disk. So in case of the node failure, you can just restart the node and the data are still there. They are persisted on the disk, and you are still accessing the data as fast as a cache, as an in-memory cache. To give you a quick overview of how this is working, basically, Aerospike is storing a list of pointers in memory directly. So when a client is sending a request to access some part of the data, it will go to the memory. The memory will tell him this is the block you need to read. The process will read directly that block from the disk, grab the data, and send that back to the client. So we don't need to manage to have the OS asking for anything and etc. We are really directly going that way. So 2 hops, one in memory to find where the data reside, one on the disk to grab the data. What's important with that is the latency is stable. When you are accessing data from Aerospike, the expected response time is always the same, because the way we are accessing the data is consistent. We are not eating memory and, oh, I don't have this data in memory anymore, I need to go back to the disk, and in which file do I store that, and etc., etc. No, we are eating the memory. This is where you need to read, go to the disk, get the data, and go back to the client application. All this is done. Basically, Aerospike is a distributed system, so you can create a cluster. You don't need to instruct the cluster about anything. You just need to instruct the cluster. This is the name you have. This is the name of the database I want to create. And then the spread of the data. Oh, we are moving one data on which node. This is directly managed by Aerospike. You don't need to figure that out. And we have what we call intelligent clients. So the client library will be aware of all the data spread across the cluster. So every time you want to access a key, you are not just hitting one of the nodes, asking, hey, do you know that key? No, I go back to the second node and start. No, the application knows exactly where she needs to go to get the information. So if the data are stored in node 1, they will go to store node 1. If it's stored in node 3, the application will ask node 3 directly. So I explained the hybrid memory architecture, and then you have also multiple options depending on what you want to have as a security on your data. So you can have a synchronous active replication between different locations. So you can replicate the data in another place just to be sure that in case you have an issue with the data center, everything is fine. You can do the same, what we call with cross data center on a longer distance. So if you get different region in the world, and we can provide also a really strong consistency, just like an ACID database. If I go back to the beginning of this presentation, I hope you have followed me for that long. I was showing you that the application is usually composed of users sending requests to the load balancer and accessing web servers, all of them trying to access some databases, eventually there's perhaps some cache and etc., and moving the data, managing the data, the liveness of the data between the database and the cache, and updating, etc., etc. Now you can simplify the stack by just having your web server. So the requests are still coming to the web server. We are not changing that, but then the web server are directly talking to an Aerospike cluster, and you will have the same response time as a cache. No problem with that. The only thing is the data is persisted, and then when you update something, or you create a new record or whatever it is, then the cluster will immediately store everything. And when you try to access the same record, you will get the latest version of it without managing a cache, without managing anything. It's just directly the application and asking and requesting data directly. Andrea.
Veamos lo que Nicolás presentó aplicado a una historia de éxito con números increíbles. El sistema IPAPAL es uno de los más avanzados que existen. En la diapositiva se habla de 280 millones de dólares, pero ya estamos a nivel, en 2024 ya estábamos a nivel de 1 trillón más. El gráfico de fraude de PayPal utiliza una red neural muy avanzada, datos utilizados para la inteligencia artificial. El objetivo es mitigar el riesgo de fraude, responder en términos aceptables, en un tiempo aceptable para el usuario. Son clientes Aerospike desde hace muchos años y nunca han tenido una interrupción que no sea planificada. Bueno, ¿cuáles eran los desafíos del business, del negocio, cuando empezó el proyecto? Bueno, se hablaba de 150 millones de usuarios. Cada usuario hay que considerar, se registra, paga, tiene diferentes modalidades de facturación. Debe tener un perfil en términos de IP, de ubicación, etc. Uno de los otros aspectos un poco delicados por la puerta en la cual se puede abrir la fraude son los movimientos frecuentes de los usuarios. Los usuarios se mueven, utilizan dispositivos diferentes. Cada transacción de pago requiere cientos de lectura y escritura en las bases de datos. Y la latencia, los LA, el nivel de servicio que PayPal había ya decidido en este entonces, abre una ventana de tiempo específica. ¿Sí? En esta ventana de tiempo no se ha podido ejecutar todas las transacciones necesarias, por ejemplo, la que tienen que ver con el algoritmo neural de inteligencia artificial para algunas verificaciones. Nada, se corta el trabajo y se contesta al cliente. A lo mejor se contesta negativamente, diciéndole que no se puede efectuar la transacción. Pero no se puede hacer esperar al usuario más del tiempo slot, de los slots decididos. Otros términos decididos que se han definido en el momento inicial del proyecto tenían que ver con la escalabilidad, ¿no? El sistema tenía que ser escalable, por ejemplo, de 10 terabytes a 100 terabytes, de 10 billones de objetos a 100 billones de objetos, etcétera, etcétera. ¿Cuáles fueron los resultados o los beneficios obtenidos? Bueno, antes se utilizaba Oracle Rack con Master Terracotta Cache, combinación de los dos, y necesitaba más de 360 servidores. Luego, con Aerospike, solo 20 servidores. En práctica se redujo el sistema de apoyo de 15 veces, el que desde luego hace que resulte un coste, un tiempo de mantenimiento mucho menor. El Service Level Agreement, del cual hablábamos hace un rato, se ha reducido tanto que hubo la reducción del 3000% de falsos positivos. Un falso positivo es terrible porque un cliente que está haciendo una transacción perfecta, normal, y se encuentra como un falso positivo, es difícil que luego regrese a utilizar la plataforma, busca otros caminos. Entonces, los falsos positivos son posibles clientes que se van. Bueno, vamos a la slide, a la diapositiva siguiente. Antes y después. Lo que ha pasado antes, lo que había es que el 1% de las veces, 1.5% de las veces, el algoritmo de fraude simplemente no se ejecutaba. Después, prácticamente el número de veces que no se ejecuta es cerca de 0. Entonces, con Aerospike, PayPal pudo ejecutar todas las transacciones, prácticamente todas, sin riesgo. Bueno, esta es una información pública, entonces la podemos compartir. A la izquierda vemos el grafo de las fraudes. Es un grafo en tiempo real. Todo esto se ejecuta en el momento mismo que el cliente pide una transacción. Mientras a la derecha tenemos un gráfico online, porque además de la fraude hay también el asunto de reciclaje. Se debe averiguar, hay la necesidad de averiguar que no haya reciclaje de dinero sucio, ¿no? Entonces, hay un algoritmo en background que averigua todo lo que necesita averiguar. Nicolas, can you please say something more about this slide, please?
Yeah, so basically the idea is with Aerospike, you are not necessarily stuck with a key value store. You can leverage some graph service or even now vector service. And in the specific case of PayPal, at the beginning, the really beginning, they were only storing key value data and want to access some kind of metadata to prevent fraud. So just grabbing the data about to score transaction and ensure that the scoring is done as fast as possible to prevent an issue. The way they use the graph was really to leverage a bit more intelligence directly from the data and leverage more information. Not only I have an information about a transaction, but perhaps I can immediately, without leveraging complex stuff and etc., just try to find the relevant information that will help me directly refine the scoring of this specific transaction and have a better understanding of is this a fraud or not, and how I can analyze that. So you have the real-time part of that, and also the near real-time, which is really afterwards trying to understand, do I need to leverage some control or not on the transaction that I just passed at the moment. So it's really what's important in that case is really they already have the data in Aerospike cluster. It's just a stack on top of that provided by Aerospike that help them use the graph way of querying data to gain some more intelligence around scoring a transaction and preventing fraud.
Gracias, Nicolás. Vemos si hay preguntas. Eventualmente si la pueden poner en la chat. Bueno. ¿Cuáles son las ganancias financieras típicas observadas durante una migración a Aerospike? Es una pregunta interesante. Nicholas, what are the typical financial gains observed during emigration to Aerospike?
So the correct answer and the honest answer, it depends. But usually, as I explained, we are not storing data in memory, but we are storing data on disk. And so it means that basically people need way more, less physical server just to store the same amount of data. So when you try to leverage an in-memory database to or distributed cache across multiple applications, you can have a ton of nodes that will spread across your IT environment. And in many cases, we are seeing somewhere between 80 to 90% reductions in this IT hardware directly. So if you get the number of servers, I'm not talking directly about the financials because then you can have some license fees and etc. So it's hard to compare without knowing from where you're going, depending on what you are paying on another solution. But just on the servers, looking at the servers, to give you an example, we had another webinar a few days ago with Stanton where they go from 24 something like that servers to only 3. So it's just the amount of server they have reduced because they don't need more than that. And they are, I think it was even more than that. Perhaps Pierre, if you are on, you can give me the correct number. But it was really a huge compression because the amount of data was able to be stored on disk quite efficiently. You don't need to have so much memory, and only 3 small server, standard production server, are enough for them nowadays. We have other use cases at large scale, in that case, where we have moved some customer from 5,000 more servers to only 1,000, so reduced by 5 times the number of the cost in hardware directly. So it depends, but usually it's a good one.
Bueno, hay otra pregunta. ¿Aerospike es adecuado para pequeñas empresas o solo para grandes organizaciones?
So basically, if I go back to the first question, so the cost reduction in IT infrastructure, for example, in a large organization, it's usually where you have the biggest gain, just because you are using way more nodes, way more servers, and then when you move to Aerospike, you can compress this number to a really smaller one. But at the end of the day, the problems you have in a small organization are kind of the same as a big organization, not at the same level, not at the same numbers. So perhaps you only have 20 servers in your organization or 20 cloud instances, not 2,000 or 20,000, I don't know. But the problem is also you don't have that much people to manage this. And if you look at the number of people managing the nodes, especially in smaller organizations, they are not only managing the infrastructure, they are managing other stuff, just like developers. They are developers of the application. They are managing a ton of things. So as soon as you can reduce the complexity of the solution because you can use less nodes, you can use a technology that is relying mostly on something that is not subject to issues just like memory and more on disk that is more stable than memory. It means that basically, usually you have less issues with that kind of solution. The experience shows that Aerospike is really, really stable, and people are experiencing, without doing too much stuff, 4 nines of SLA, and they don't have to worry a lot about the cluster by itself. It's more on the application. So even a small organization will benefit from that because they can just start the cluster and let it live its life, throw a request at it, and they don't have to care about. And one important thing also to note is when you're a small organization, perhaps one day, it could be in 1 year, in 10 years, you will be a large organization. And if you need to start with a solution that is not able to scale up to where you will go, at some point in time, you will need to manage a migration. So if you start directly with a solution that is working fine and you can scale up, then you're good.
Thank you, Nicolas. So thank you, Nicolas, for your help, for all your speech.
Thank you for having me, and next time I will try to do it in Italian.
No, wonderful, meraviglioso, va bene, grazie a tutti per essere stati con noi, davvero, e spero di incontrarci presto in un altro incontro come questo. Grazie, un saluto a tutti.